We're going to show you how to prep for running a CAM test here. Here's our CAM analyzer, and we're going to point out some features of this program before we actually get into starting a test. Uh, we got an existing test here, and usually when you start a new test, it is best to start it from a previous test. You can start with a blank test, but then you have to be putting in more information. So we're going to start from a test we've run before. This happens to be a small block Chevy that we've run before, CAM, and we're going to run another test on a small block Chevy. Doesn't have to be the same CAM, but it's a small block Chevy CAM. I'm going to click up here on Test and CAM Setup. This is what kind of determines what you're going to do for a test, how you're going to run your test. A lot of information is contained here. This type of CAM data is probably the most important setting in the whole program. With this, you're going to determine what kind of a test you're going to run. And right now it says measure with electronics. That means we're going to use the CAM test stand. But there's all sorts of other things you can do in our CAM analyzer. When we first did the CAM analyzer 15 years ago or something, it was designed to be a poor man's CAM doctor, where you would make measurements by hand with a dial indicator and degree wheel, and you could measure out a CAM reasonably quick. We got some features in here to make it quick, but it was not nearly as accurate or fast as you can do with a CAM test stand. You can also just generate some generic CAM profiles, some typical CAM profiles based on some 50,000 events, 40,000s, or advertised duration events. That might be nice for comparing what's a typical 240 duration at 0.33 lift look like compared to my CAM profile. We can also read lots of different file formats. CAM Doctor, CAM Pro Plus, CAMS has a format they use, Doctor Doctor, S96, Andrews. And what we do here, what we're going to show you today is measure with electronics. Okay, when we measure with electronics, a lot of the inputs you would normally see are replaced by this electronic measurement settings. But there are some settings up here that we use from what settings we use for those other setups up there. One of them is here, lifter profile type. At this point in time, at this version of the program, what we use this for when you're measuring with electronics is basically, is it a hydraulic or is it a solid? In the future, we may differentiate between is it a roller or a flat, but right now it's basically, is it a hydraulic or is it a solid? And so basically the thing to do is pick the correct type. And here for what cylinder you're going to measure, that one is not really used too much for measuring with electronics. These two settings are used because we're measuring a cam, we're getting lobe data. You might want valve lift data. So you might want to know what it is at the valve, so you put in a lash and a rocker ratio, and then we can see calculate out what the valve lift would be doing. Okay, here's the important measurements or settings if you're doing it with electronics. The first one here is when you're measuring a cam on the cam test stand, unless you got our TDC checking bridge, a new feature we got, you don't know, the program does not know how you're going to install that cam. You could have an offset bushing, it doesn't know what the timing marks are, etc., etc. So it says, give me something to go on. And the most reliable thing when you're doing it this way is, I would say, use intake centerline. Nice thing about intake centerline is it doesn't matter what the lift is, the actual minimum lift. And when you're measuring base circle, a lot of times there can be what's called runout, variation in base circle. You might have 4,000 runout on base circle. So it's kind of hard to know exactly where zero lift is, or where zero lift by what the cam grinder thinks it is when you got base circle varying by 4,000. So if you choose some of these other methods here, like intake lift at TDC, 50,000 lift, 1 millimeter lift, exactly where 50,000 lift is a little hard to determine because, you could have 3-4 thousandths of runout. So I like intake centerline the best. I'd recommend that you do that also. Now, if you have, don't get me wrong. You can use this if you know what's going on and you say, I want to put this cam at 38 thousandths lift the TDC, then use that. But I'm just saying, for most situations, when you're measuring a cam, I'd recommend intake centerline. Okay, cam timing value. What is the intake centerline? Nice thing again about intake centerline is if you don't know much about the cam, you can put in 110 degrees and be fine. 110 or 108 are good numbers for most any cam. If you went with some of the other settings, if you got a 300 degree duration cam versus a 200 degree duration cam, that's a 50-degree difference in the opening event. And so that's why I just recommend just use intake centerline in most situations. Put in, we saying 102 here because we know this cam is advanced. That's why we're using 102. We know we want to install this at 102, and that's why we're saying it. But if you don't know anything about the cam, I would say intake centerline and 110. This is a very powerful setting here. What is the cam design? This is what's going to determine what the lobe layout is, firing order, and a whole bunch of stuff. We've got lots of these already pre-programmed in the program. So ideally, you're going to find something we've already pre-programmed, and that's going to make it easy. Number of cylinders to test. This thing has 8 cylinders. We're going to test all 8 cylinders. No real downside to calling it 8 and you only test 4. You can still work fine with it. So we usually say use all the cylinders that you got. Set it to 8. Now I'm going to get into some details here. And this has to do with this setting right up here, small block Chevy. And I'm going to look at the lifter bore angle details. I'm going to click on this. Little message pops up that says if I change anything in this screen, it's going to say here, I'm going to drag this down. This is no longer a small block Chevy provided by Performance Trends. You're kind of on your own. It's going to change this into user defined. Just to let you know that if you go back and look, that you know this thing doesn't make sense. You say, oh, it's a user defined profile or cam design. Maybe I had some settings wrong. That's what it's saying here. So, but we're not going to change anything. We're just going to look and see what this stuff is. A lot of people don't think about this much, but if you look at the front of a V8 engine, you see the lifter bores. You see the bores themselves are split by 90 degrees typically. But the lifter bores may not be. And in the small block Chevy, they're not. They're actually separated by only 82 degrees. And the program needs to know that. And this lifter bore angle here, first off, we say how many lifter bore angles do we need? If you had a big block Chevy, it's a lot of stuff. There's a lot of complications. If you ever looked at a big block Chevy, there's all the lifters are different angles. But for a small block Chevy, we only need to specify one lifter bore angle. And what we're specifying here is how many degrees from number 1 cylinder. Everything's kind of referenced from number 1 cylinder. How many degrees from number 1 cylinder is this lifter bore of 82 degrees? And I'm saying, like for example, it's 82 degrees from number 1. And then which cylinders are 82 degrees from number 1? And that cylinder is 2, 4, 6, 8. All the cylinders on the other bank are 82 degrees off from number 1. And then it says here, are they just intakes or exhausts? And in this case, the intakes and the exhausts are all 82 degrees off. Like I said, in a small block or in a big block Chevy, you're going to use all 3 and fill all this stuff up because it is fairly complicated. So I'm just going to cancel out of that. We were just looking at the stuff, not changing anything. The other thing that small block Chevy defines is right here. Camshaft layout details. I'm going to click on that. Same warning pops up. We got a lot of stuff in here. How many cylinders on this cam? There's 8. For example, in a 427 Ford cammer, the overhead cam, it's a V8, but there's only 4 cylinders on that cam. So that's in a situation where that may not be all the cylinders there. How many lobes are, what types of lobes on this thing? There's intake and exhaust lobes on this cam. If you have a, let's say, a double overhead cam 4-cylinder, all the intakes might be on one cam and all the exhausts on another. And you might say it's just intakes only, but there's intake and exhaust. How many intake lobes and how many exhaust lobes are on this cam? Again, for double overhead cam, you might have 2 intakes, and they might all be intakes on this cam. So you got 8 lobes on a 4-cylinder, but they're all intakes. This is only 1 intake and 1 exhaust lobe per cylinder. Then here's the firing order. Is it odd firing? The old Buick V6 was odd firing. A Harley Davidson is odd firing. You know where it goes ba-bump, ba-bump, ba-bump. That's odd firing. Luckily, most of the engines you're going to encounter are even firing, so you can disregard this stuff. And you see, because it's set to no, these are disabled. Here's the lobe description. This is a fairly complicated input you can see, and this is what determines how we draw out the cam. We have different letters we can put in this, and ideally, you're not going to have to mess with any of this stuff because we're going to have all your stuff preloaded. But what you can do is you can put in a journal for a cam journal. F means a fuel pump cam. So it's going to be a lobe that's basically dead. You're not going to measure it. E means it's an exhaust lobe. E1 means it's an exhaust for number 1. E2 means exhaust for number 2. I for I1 for intake 1, then I2 for intake 2, and then we have another journal. And you can put a G in here also for a distributor gear. But we've got this already preloaded for you, so it's not a big deal. So you can just use it. Okay, what rotation does this cam turn? Not the crank, but the cam turn when viewed from the front of the engine. Most engines are going to rotate clockwise. And the encoder, which end of the cam we're going to mount the encoder on? And we're going to mount it on the rear. The front has a dowel pin. You can't mount the encoder real easily on the front. So this combination here of this and this lets the program know what direction should the encoder be rotating. If you rotate the cam the wrong direction based on these settings, what the program knows about the cam you're measuring, it'll beep at you saying, nope, you're rotating in the wrong direction. So let's cancel out of here. We're going to cancel out of here, get back to the main screen. Okay, so we're going to start a new test here. We're going to click on File, and we're going to click on New. And it says, do you want to save any of the changes you've made here? Because I've been playing around now. I don't want to save any changes. But it lets you know the program's always watching to make sure you don't throw away data that you may want. I'm going to say, nope, I don't really care about that. So here's our new test screen. In this screen, we put in front of you all the things we think are very critical to get your new test started correctly. And that is, let's say, operator name, maybe a cam grind, or some of these inputs, what folder you want to store it in. This is important here. You can add a new folder. For example, maybe you want all your small block Chevys in a certain folder, all your big block Chevys in a different folder, maybe a certain customer name in a particular folder. We always give you in a new program my tests. So that's the one it'll default to if you've not entered any other folders. Here's an important one right here. Are you using electronics, yes or no? If we check that off, you can see a lot of critical specs go away. If you turn it on, here they are back. And we went over this stuff before, but it's just basically carrying over what we've got currently set up. We got our 102 center line. We're going to measure all 8 cylinders. The cam design is a small block Chevy. The spring tester demo, I recommend you run the spring tester demo also because the programs are very similar. It goes into a lot of this stuff also. But here, if I click on C specs, here's a screen we were playing with before. And maybe I know on this one, I want to change that to 1.6. And I know I want to change this rocker ratio to 1.6. And I go back, and then now I'm at the new test screen. Now, if I cancel out of this starting a new test, and I go back and look at the rocker ratios, they're not going to be 1.6. The program will say, you didn't start a new test. Those changes you made only applied for this new test. So they're going to be back at 1.5. The nice thing is you're not going to screw up this test we got on the main screen of 02 because we never ran this 03. And we said, where did this 03 come from? The program automatically takes whatever's the last number in your test file and increments it up by 1. If there is no number on the end of your test, it's going to put a 1 there. It's just a nice way of the program making sure that you don't overwrite your old data with this new test data. So I'm going to say, and let's say I want to carry over these comments. I could blank out these comments by unchecking it. I could type in some new comments, and you can type new comments in after you get started in your test also. But I'm going to go up here and say start a new test with this name, and there we are. We're on the main screen with a blank sheet of paper. Now, before we actually start our test, I want to show you settings up here. This is some important things, tester calibration, and a lot of these things you're only going to set once in the program. You're not going to be changing this stuff very often at all, especially cam tester specs. Um, if you don't put anything in here, the program's going to assume you got our stuff, and it's a 2500 pulse encoder on the rotary encoder. Because it has quadrature, it actually has four times more pulses than you see there. There's actually 10,000 pulses per rev on that encoder, so it's very, very precise. Um, what kind of electronics? The black box 2 is what most everybody's going to have if you got our cam test stand. Our software will work with the Cam Pro Plus electronics also. If you have Cam Pro Plus and you want to use our software, we can do that also. But for us, it's got a black box 2. And which COM port are you on? A lot of people may not even understand that. If you don't have a COM port, you're going to have to go through a USB adapter. Then it can assign a COM port of any number. And if you don't know how to go in the control panel and stuff, we just have this automatic feature here of Find It. It says make sure your box is turned on and it's connected to the computer. And do you want to continue? Yes. And what the program's going to do, like it said here, it said it found it on COM1. It's going to go through all the COM ports on your computer and check to see, can it find the black box. Makes it real easy for connecting. And it found it on 1, so you say, okay, use that, and here it is, it's COM1. So I'm going to back out of this. I'm going to click on settings again and go into preferences. Here's a lot of things that let you customize the program for perhaps, what floppy drive you want as the default, what kind of printer you got, things like that. Here's an important one, inches or millimeters. Do you want to measure in millimeters or inches? Most people in Europe obviously want millimeters. Some lists up here, standard lists for reports. This is where if you need duration and stuff specified at a particular lift that we don't by default do, you can say, you want to use standard, and you say no, and now you can type in most any lift that you want here, and you'll get that data reported at that particular lift. I'm going to turn that back to yes. Here's the ones that are important. The preferences important for electronics. Do you want to auto advance to the next lobe? If you measure a lobe, do you want to automatically jump to the next lobe? Most people are going to say yes, and it makes it for much faster testing. And it says the next lobe is based on either cylinder number or cam lobe position, and your choice there is whatever you want. Warn if turning the cam too fast. That can be a nuisance. The program is very forgiving. I'll talk about that in the next demo. But for a lot of people, that warning gets to be a nuisance. So we turn that off for a lot of people. Warn if accelerations are found too high. That can be handy. And again, you can turn it off. But high accelerations usually mean bad data got in there. You got a bad data point for whatever reason, and leaving that on is probably a good idea. Percent difference from number 1 cylinder to flag out. We're assuming that that most of the lobes on the cam are going to be very close to number 1 cylinder. So if you measure number 1 cylinder intake and it's 240 duration and 0.33 lift, and the next one in cylinder 2 is 248 duration, that's more than 5% different, or maybe it's not, but let's say it was. It would say, this looks really different. Are you sure you got this right? Are you sure you're doing things right? And it will warn you. You can still keep the data, but it'll warn you that something looks funny. Most of the time, it's not going to be duration and lift that's going to be 5% different. It's going to be the acceleration, the peak acceleration over the nose, or the 2 peak accelerations on the opening and closing ramps. That's where it can get a little fussy. And but it's going to check that to see that the accelerations look pretty similar. And again, if you're 5% different from number 1 on the other cylinders, you may have a bad data point. You may be turned in too fast, or there might be a problem. You may want to remeasure it, and that's what it's going to do. Say, do you want to remeasure it, yes or no? You can say no and just keep the data and see what it looks like. So anyway, I just wanted to point that out. So here we are on the main screen. 2 important things here to show you. Up here across the top, we have tabs for the different cylinders. Intake 1, exhaust 1, intake 2, exhaust 2. I'll click on exhaust 2. It's no data in there, so that's why it's blank. And you can see down here when I did that, it highlighted in or exhaust two's position on the cam. This is that, remember that that layout, that J and the F and the E1, E2 and all that stuff. That's what this drawing is based on. Here we got the gear for the distributed gear, and it shows here's the rear of the cam, and it's showing the encoders mounted on the rear, just a reminder for you, and here's the front of the cam. And right now we're on exhaust 2, and up here we're on exhaust 2. But this is in the cylinder number order, I1, E1, I2, E2, and this is the order going down the cam. So that concludes the demo. The next demo we'll talk about how we're actually going to run this test.